question 20. Express the composite function gf in the form gf da da da. So basically we take f and we substitute that into g. So we take f here and we substitute that into g. So wherever we see an x, we substitute in 2x squared plus 1. So we have two lots of 2x squared plus 1 and then a single lot of 2x squared plus 1 minus 1. So that's here. So to remember this, you start off with f and you substitute that into g. So you work backwards. Okay, f into g. So we then just need to tidy this up. So let's just start off by simplifying the denominator. 2x squared plus 1 minus 1 is obviously 2x squared. The 2's then cancel, so we're left with 2x squared plus 1 all over x squared. Now for part B, express the inverse function of g to the minus 1. So basically we just need to change the subject here. Okay, we need to change the subject of g. So let's start off, just so we don't get in a muddle, by saying let's call it y equals 2x over x minus 1, and we're just going to do the algebra required to make x the subject. So we need to start off by making a one level problem. So how do we undo a dividing by x minus 1? We multiply both sides by x minus 1. Y times x minus 1 is xy minus y. So xy minus y equals 2x. We then rearrange to get all the elements the terms which include an x on the one side, all the terms that don't include x on the other. So I want to get all, so I've chosen to have all my terms including an x on the left hand side. So I'm minusing 2x and at the same time adding y. So here I have it with all my terms involving x on the left, all my terms not involving x on the right. I can then factorize, so I've got x, y minus 2 equals y, and so that's the clever bit, because I've now isolated x on its own, so I can now just choose to divide through by y minus 2, and I get x equaling y over y minus 2. Now remember, y is just some term I introduced just to help me. I mean, y is not part of this question, so my final answer, I just go back to giving my answer in terms of x, which is what the question involves. So x over x minus 2. So I've just reversed the whole function.